Okay, lesson 21. This is your final lesson before a midterm assessment. Just giving you a heads up. Alright, opening exercise. The figure to the right represents a rotation of triangle ABC 80 degrees around vertex C. Name the triangle formed by the image of ABC and write the rotation in function notation and name all corresponding angles and sides. Okay, our new triangle, if we're going ABC, so we have A, B, C, just want to go in the right order. So ABC is EFC. Erase that mess. So we just named the triangle formed by the image of ABC, triangle EFC. Write the rotation and function notation and name all the corresponding angles. So let's do the rotation. So we have a rotation about C, 80 degrees, of triangle EFC. Actually, hold on. Of triangle ABC, I don't know why I wrote B, probably because my triangle looks like an A, goes to triangle EFC. Now the corresponding parts. First we're going to do the angles. Angle A, angle B, angle C goes to angle E, angle F, and angle C. Let's actually make that look like an F. And the sides. We have AB, BC, and CA. AB goes to EF, BC goes to FC, and CA goes to EC. That's it. Okay, let's discuss it. In the opening exercise, we explicitly showed a single rigid motion which mapped every side and every angle of triangle ABC onto triangle EFC. Each corresponding pair of sides and each corresponding pair of angles was congruent. When each side and each angle on the pre-image maps onto its corresponding side or angle on the image, the two triangles are congruent. Conversely, if two triangles are congruent, then each side and angle on the pre-image is congruent to its corresponding side and angle on the image. Okay, that's what we're talking about today. All right, let's look through an example. Quadrilateral ABC is actually a square, and segment AC is one diagonal of the square. Triangle ABC is, so here we have triangle ABC, is a reflection of ADC across segment AC. Complete the table below, identifying the missing corresponding angles and sides. So our corresponding angles, let's look. Angle BAC corresponds to DAC. Let's actually write the angle in there, sorry. Angle ABC corresponds to ADC. Angle ADC and BCA corresponds to DCA. Angle DCA. Corresponding sides. Segment AB. Segment AB corresponds to segment AD. Segment BC corresponds to segment DC. And lastly, segment AC corresponds to segment AC. Are the corresponding sides and angles congruent? Yes. Okay. Because a reflection is a rigid motion. Sorry, a rigid transformation. That says, yes, a reflection is a rigid transformation. That means that all sides and angles maintain their size. Is triangle ABC congruent to triangle ADC? Yes. Since triangle ADC is a reflection of triangle ABC, they are congruent. Very cool. Okay, these are some exercises. So remember, exercises you're going to complete until you feel pretty comfortable. There are, let's see, 1, 2, 3 exercises. So whatever you feel comfortable in. Each exercise below shows a sequence of rigid motions that map a pre-image onto a final image. Identify each rigid motion in the sequence, writing the composition using function notation. Trace the congruence of each set of corresponding sides and angles through all steps in the sequence, providing that the pre-image is congruent to the final image by showing that every side and every angle in the pre-image maps onto its corresponding side and angle in the image. Finally, make a statement about the congruence of the pre-image and the final image. That's a lot of stuff, and I'm pretty sure I'm not going to be able to fit it in those itty-bitty little boxes. All right, so we have our pre-image and our final image. And it looks like our pre-image is solid line and our final image is dashed line. So we are going to do looks like a rotation first and then a translation. But what I'm concerned about is, oh no, the rotation's counterclockwise. We're good. So we have 2 rigid motions, a rotation and a translation. Composition and function notation. Remember, we are on the inside first, so a rotation about C, and at this point you would need your compass to measure from here to there. I'll tell you it's 90 degrees of triangle, let's name the triangle correctly, ABC. Parentheses around that. And translation. Translation looks like it goes from B prime to B double prime. That's a double prime. Cool. There is our function notation. Sequence of corresponding sides. Let's see. AB, BC, and CA. Those are all segments. AB goes to, I believe it's, let me look real close in the paper. AB goes all the way through a single prime to a double prime. So a double prime B double prime. BC goes to B double prime, C double prime. And that's a segment. And CA goes to C double prime, A double prime. And that's also a segment. Okay, you're going to have to listen to my words as I write too, just so we don't miss anything, and my handwriting is struggling in these small spaces. So sequence of corresponding angles. We have A, B, and C. A goes to A double prime, B goes to B double prime, and C goes to C double prime. And the triangle congruence statement. Triangle ABC is congruent to triangle A double prime, B double prime, C double prime. Awesome. Okay, I'm going to number these because I don't want to try to squeeze everything in. I might need another slide because I didn't leave much room. All right, so our sequence of rigid motions. Let's look. So we're going from this piece to that piece to this piece to that piece. So let's start that over. We're going from 1 to 2 to 3 to 4. Cool. Sequence of rigid motions. I see way more than 2. I must have copied the wrong table for this guy. That's okay. There are definitely 3 motions. So for boxes, first we're going to do a reflection, then a translation, then a rotation. Number 2, the composition and function notation. So going from the inside out, we're going to start out with that reflection. So our reflection is a small r over line ED, or segment ED, or DE, of triangle ABC. Then we did a translation, B prime, B double prime. Then we did a rotation about a triple prime, and we would need our compass to figure out our angle. The answer says 100, because I did not bring my compass home. And that gives us, it's not asking that. So there is our composition and function notation. 3, sequence of corresponding sides. We'll get this one on this page, and then we'll move to a new slide. I always list them first. AB, BC, CA. These are all segments, and they move to, pretty simple, B triple prime, C triple prime, and C triple prime, A triple prime. Very cool. Okay, our sequence of corresponding angles. I think I can fit this one on here. Angle A, angle B, and angle C goes to angle, angle A triple prime, angle B triple prime, and angle C triple prime. Let's fix that. It's definitely an angle symbol. And then number 5, the triangle congruence statement. Triangle ABC is congruent to triangle A triple prime, B triple prime, C triple prime. Okay, last example. sequence of rigid motions. Again, it says 2. There's definitely more than 2 here. So we are going from triangle ABC to triangle XYZ. It looks like we're reflecting it here, reflecting it there, and then reflecting it there. There are definitely 3 though. Composition and function notation. Let's see. I'm going to label this up here A prime because it's mapped here onto there. Sorry, we're going to start over. That point. So first I'm reflecting this triangle over this line to this triangle. And then I'm going to reflect over this line, which has 2 letters here, very confusing, this triangle over here. And then I'll reflect over this line down there. Cool. Let's try to write it down. Reflection, first we're going to go reflection over segment BC of triangle ABC. And then another reflection, so we just did over this line. Now let's go over AX. And then we'll reflect again over this line, XZ. Cool, that was our, so we'll do this again. That was number 2, composition function notation, sequence of corresponding sides. AB, BC, and CA goes to, let's see, AB flipped up here, then it stayed there, then it went down here. I think it's XY. I'm going to check that again though. So AB first reflected over this line, so AB goes up here where that's A prime, and then we reflect over this line so it stays, and then we reflect over this line. Yep, I think that's right. BC, so here it is, it reflects on itself, and then it goes over here, and then it reflects on itself. So BC would go to XZ. And lastly, CA over here. So CA reflects up here, then it reflects over here, so that's C, and then down here. So CA goes to ZY. Cool. 4. Sequence of corresponding angles. Hold on. Oh no, CA, why is, I was just checking the answers. Looks good. So let's do the angles. A, B, and C. Angle A ends up at angle Y. Let's see, angle B flips up, flips over, flips down, angle X. And angle C stays there, goes over here, and then there, angle Z. And then 5, the triangle congruence statement. Triangle ABC is congruent to, and I can look at this, ABC is congruent to YXZ. Awesome. Okay, in closing, when each side and each angle of a triangle on the pre-image maps onto its corresponding side or angle on the image, the 2 triangles are congruent. Conversely, if 2 triangles are congruent, then each side and angle on the pre-image is congruent to its corresponding side or angle on the image. Nice job.